So, good afternoon everyone. So, in today's discussion, we are going to talk about the importance of Laplace transform and importance of inverse Laplace transform in real life. So what was the recent topic we discussed in our class related to Laplace transform? Any idea?
Earlier we have discussed Laplace transforms in our class, like periodic functions and groups. So can we use these Laplace transforms in ECG systems?
So as she asked, we discussed about Laplace transform in periodic functions. Periodic functions that we can connect. Usually many of the signals we work with in engineering are periodic in nature. So because it repeats itself in a certain time. So that is called a period. So usually we say sin x, cos x, sin is a periodic function and cos is a periodic function, the period 2 pi. So these periodic functions can be studied, can be analyzed using Laplace transform. For example, as we asked ECG. So it's an electronic device where we try to understand the heart movements, heart beating, that kind of things. So we can see in medical. So the ECG is again a kind of signal processing. So signal processing is happening. So this Laplace transform is used in ECG system in order to avoid noise. For example, I'm speaking here, the camera is there, it is recording. So along with my voice, some extra background noise is getting mixed with it. So we use noise filter, right? There are some noise filters created by us. So it is applied in order to remove the unwanted noise. Similarly, the same kind of system is used in ECG. In ECG, what we do is there is a programming concept inbuilt in that which removes waveforms with 60, that is a frequency of 60 Hz, more than 60 and more than that. So that unwanted noise, usually unwanted noise will be of huge frequency. So that will be above 60 and above. So it will be obviously removed. So in order to remove that noise, certain noise filters are used. So in that area, we use Laplace transform. You all know Laplace transform is a concept connected with integration. So integration is very well connected with signal processing. So signal processing is the place where we use Laplace transform, where we understand the signal spectrum. So you know signal is moving in a waveform, so we have a spectrum. So that spectrum can be analyzed and we can visualize what are the unwanted waves mixed with it. We can use some noise filters, there are various noise filter parameters that we can connect and remove those things. And again, we can retrieve the proper signal what we need. So that is what is happening in this ECG system. So apart from ECG, there are various areas we use Laplace transform. Even in engineering side, whenever we come across mathematical modeling with differential equations, can someone say what is the importance of differential equations? So usually when we measure rate of change, the change of certain thing with respect to something, that is called rate of change. So that rate of change is analyzed, is measured using differential equations. So complex differential equations can be simplified, can be solved using inverse Laplace transform. Similarly, if Laplace transform is very much useful in, as we discussed in periodic functions, that is in signal processing, inverse Laplace transform is very important, very beneficially used in differential equations. So differential equations can occur in any place, wherever there is a rate of change, with respect to some parameter. So in those areas we apply Laplace transform in order to simplify and in order to solve and retrieve the solution. Usually you know Laplace transform is very useful in order to convert the domain. In Laplace transform what happens? Previously the function will be in what variable? T variable. So T variable, time domain. From time domain we convert to another domain. We use the symbol S. That happens in Laplace transform. Then what for retrieving purpose what we use inverse Laplace transform. In inverse Laplace transform from S domain again we retrieve to T domain. You very well you are also seen many functions. That will be the function will be in S format. You will be applying inverse Laplace transform so that you will get the answer in T domain. So in engineering, in real life, there are situations from one domain to other domain conversion has to happen. Previously we discussed about the conformal mapping in our class. Conformal mapping is a mapping happens from W plane to Z plane. So from a complex plane to Cartesian plane. So because not everything can be studied in a single domain, in a one particular domain. So there are situations where you have to convert to another domain and you have to analyze what's the real fact, what we have to do. Then we can return to the back format. It can be done. So Laplace transform and inverse Laplace transform plays a very important vital role in engineering, especially in signal processing. Thank you.